Hey all, welcome back. So we are at part 3 now. If you have missed part 0 and part 1 and part 2, I'll put the link in the description. Please watch them because this is a continuation. It'll be very confusing otherwise. So we have set up our database or databases, and we have set up our sync. So all the masters are now getting synced and the locals are isolated, right? And now we'll start running some tests, which is the fun part. The goal over here is the sync should be absolutely dumb, by which I mean like I should need no manual conflict resolution. If there is a conflict, I can just blindly delete the conflicted files and it should still work in an eventually consistent way. Let's see if it does really work that way. So let's bring up our KeepassXC database again. One thing you'll notice is whenever a database changes, there will be a star mark next to it. So that is how we know that a database has undergone a sync, right? So keep an eye for that. I'll keep an eye as well, and I'll let you know like if I see something. So the first test is one entry in 1 DB, and we expect all of them to be updated. So let's just randomly select a DB. Let's select 2. So let's go to its master. The shared folder, new entry, and let's call it 2's entry 0, right? And okay, so there you go. So none of them know about it, but we will see all of them get updated sooner or later if the sync is working and if KeepassXC is also working as expected. There you go. 3 has a star next to it, so 3 is synced. 1 has a star, so 1 is synced. 0 still doesn't know about it, so we're just waiting for 0. At some point in future it is going to know about it, and I just need to wait for it. Okay, there you go. Took a long time, but we got there, right? So now everything is synced with everything, and they all have the same view of the network, right? Everybody has 2.0, right? So that passes. That was a simple test. This one just extends it. So we are going to put 2 entries, 1 in each DB, and then everybody should get updated as well. So let's just randomly select 2 DBs. So let's select 3, put an entry over here, call it 3.0. We'll save it together just for fun. Let's put an entry here. So this is 1. So 1's 0th entry. Let's save this. Let's go to 3. Let's save this. Right. So nobody knows about 1.0 except 1. Nobody knows about 3.0 except 3. Right. And we should see some star. Yeah, there you go. 1's updated with something. It's a suspense. Let's keep waiting. There'll be a lot of network churn because they'll be overwriting each other's stuff, generating conflict files, but we don't care about conflict files. Just by the overwriting itself, it should become eventually consistent. There you go. 0 is syncing. 0 synced twice because it probably got like 2 conflicts or something like that. There you go. And 2 has synced. So 2 has both 1.0 and 3.0, right? And this guy has 1.0, 3.0. And this guy also has 1.0 and 3.0, and this guy also has 1.0 and 3.0. So again, all of them have an identical view of the database. Now in the meantime, if I do a tree here, it should have generated a lot of conflict because the Syncthing will just see the timestamps. It will see that this change is more recent than the other change, so I'm just going to overwrite it, and I'll put the other change in a conflict file. So you can see like all the conflict files, but we don't care about these conflict files, right? Nobody in the network cares about these conflict files. So our mechanism to deal with conflict is as dumb and simple as just deleting them. So find minus name, what's the syntax? Says star, I think sync conflict, FLICT. Yeah, that should be enough, right? And you just delete it. Okay. There you go. So we don't care about conflict, so we are back to normal, right? That's all you got to do. From time to time, come back and just delete all the conflict files because we just don't care about the conflict files. And it's still working, so that's great, right? So let's go on to the next test. Stop the sync, okay? So that will simulate you going offline. For example, if you are only syncing over your LAN, and say you go out with your mobile phone or your laptop or someplace, so you're no longer syncing with anybody, you are offline basically, and when you come back, everything should sync back again, right? Make local changes and quit. Network comes back, restart the databases. Okay, so we are also going to stop the database so that it doesn't have an in-memory view of anything, right? So if you stop the database, and if something gets overwritten, because the local changes are not yet synced, and say the database is stopped and something gets overwritten, the data is lost forever. That would be the case if you didn't have master local sync. But because we have master local sync, you can go offline. Your database, the master database, might be overwritten, and you should still be able to recover. So that is what we are going to test now. So let's go and stop the sync first. Where is my browser? There you go. So go to this guy, pause all. Right, go to this guy, pause all. This guy, pause all. This guy, pause all. So everybody's paused, right? Nobody's syncing anything at this point. And now we'll make some changes. So let's say laptop 1 makes a new change, new entry called 1.1, right? And laptop 3 or laptop 2 creates a new entry called 2.1, right? So there you go. So nobody knows about these changes. They will never sync because the sync is paused. So only 2 knows about 2.1 and only 1 knows about 1.1, and the rest of the people don't know about each other. At this point, let's also simulate that we have gone offline. So we are not even actively monitoring anything. So close, 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 database close. There you go. KeePass is completely offline. Nobody's monitoring anything. So now we'll go back and resume our sync. Resume, right? Give it some time, let it override everything, and then we'll open up our databases again, and let's see if the master local really works. So in the meantime, let's go to tree view. It must have generated some conflicts by now. There you go, there are conflicts already. Give it some time. It seems reasonably calm. Maybe the network churn is over. So now let's open our databases. You can just open it from here. So 0, the password was 0. Let's open 1. Where's my database? Let's open 1. Let's open 2. Two was 2. And let's open 3. And 3 was 3. Right. Now let's see if everybody has the same view and no data loss, right? There you go. So this guy knows about 1.1 and 2.1, and it already knew about the rest. So this guy knows about all of them as well. Let's go to 2. 2 knows about all of them as well. Let's go to 3. 3 knows about all of them as well. So there you go. Perfect. Everything worked, right? Even if you went offline with your local changes not yet synced to the network, still everything works because of the master local sync. Now let's see if we have more test cases. Multiple databases change the exact same entry in conflicting ways. Okay, this one's interesting. So far we have been adding different entries, but what if the same entry is changed by 2 databases? So the way KeePass works is it'll still resolve this by looking at the timestamps for individual entries. So if it finds that an individual entry has been modified twice, but the second time it was modified has a more later timestamp, that one is going to win, and the one that had a former timestamp or an earlier timestamp is going to go into the revision history, right? So you can still recover from it, from the KeePass interface itself, and nothing's lost, but the things are kind of synced, and most of the time you want the most recent one winning anyway, right? So let's see if that works. Let's make sure. Yeah, let's just delete our conflicts because we don't care at all, and go to KeePass. So the way we will simulate this is, let's say one modifies one as old, right? Because I'm going to save this first, so it will have an older timestamp. And let's go to 2, and 2 modifies this guy as new, because I'm going to save this new next, right? Let's do one even more interesting thing, right? So let's go to our browser and pause the sync. So it's not even syncing, so it gives us some time to kind of make all our changes. So it again simulates that things are offline, because if things are offline and if they work, then they will certainly work if they're all online, right? So this is like a superset. There you go. So now let's go back to our KeePass. So we will save the old guy first, right? It won't be synced because the sync is off, and we'll make a conflicting save over here, the same entry, but saved later, so it's called new. And let's do the opposite. Let's do the opposite for 2.0. For 2.0, this guy will be old, right? And for 2.0, this guy will be new, because I'm going to save it later. So let me first save the old guy. There you go. And now let me save the new guy. There you go. Let's see if this works, right? So this guy has an old and new, and this guy has an old and new, in the opposite order. What we want to eventually see is everyone should have new and new, and old should just go to the version history of that particular entry, corresponding entry. If that happens, we are golden. Everything worked. I'm doubtful, but let's see. Let's go ahead. Nothing's changed, right? So nobody has changed. These people don't know about the change. That's all good. So go here, resume, go here, resume. So this is simulating that everybody's coming home, everybody's joining the network back, and they're all syncing again. They were offline all this while. So now let's wait and see what happens. This will generate a lot of network traffic, I think, because somebody will get an old copy first, and then they'll realize they're supposed to get a new copy. It'll be overwritten, and once that changes, the Syncthing will resync it again, and so on and so forth. See, this guy got an old and a new, but they are supposed to get new and new eventually. See, oh, 2 is already updated. It has got both of them as new. Great, it's already worked. What about 0? So 0 hasn't realized. It's got the 2 new, but it's still 1 old. And 3 hasn't still realized. It's got old and new. So we are waiting for new and new. Interesting. That didn't generate a churn, or is the churn over? It did generate some conflict, but it seems it has stagnated over here. There is another setting in Syncthing. So if you go to this folder, if you go to advanced, it'll say that after 1 hour it will do a full resync again. So even if it missed something, I guess, like after an hour when it does like a full rescan and find out the timestamps and stuff, it might probably bring it up to speed, but not sure why it couldn't do it here. The data, however, is not lost. So let's just give it a nudge by creating just a new entry. We'll just call it 2, right? Let's see if this gives it a nudge and everyone gets a new. It's either that or Syncthing is broken. Oh, there you go. 3 is updated. And it's got foo. And did I set this old and new up properly? 2 is updated. Oh, 3 is updated again, see? And now it's got new and new. Okay, so Eventual-Consistency 1. It's finally got new and new. 1 also got new and new. Great stuff. And this guy also. Okay, so eventually now everybody has the same view of the network and everybody got new and new. For some reason, which kind of sucks, you had to give it a nudge by creating this foo, but I'm not sure whether you really had to do that, or after 1 hour it would have checked the timestamps again and then redone something and everybody would have got new and new. Let's just try one more time. Let's edit to 1 and call it old. I'm going to save this first and let L0 create it as new. Right, so let's go to 3, save this, and let's go to 0 and save this. So everybody should get 2.1 as new, including 3. Let's see what happens. Okay, so this one's got 2.1 as new. 3 has synced, but it just realized there was no change, so nothing happened. L0 has also got 2.1 as new. Good, so it does work. It just kind of sometimes. So this guy doesn't even know there's a change, so it's just waiting for the sync to happen. Come on. L0 synced again. Hope didn't change anything. Okay, nothing changed. And L2 has synced. Here you go. You saw the star. New. Okay, so everybody's got new. L1 has changed again, and it's got new as well. Let's just wait for the churn to die down, because eventually everyone's just going to realize that they have all the changes, and the master is just going to be identical, so it's no longer going to be synced. I guess we might have reached that stage now because I don't see any more churn, and everyone's got new. In case say this new stuff didn't work because your real actual password was in the old one, and you wanted the old one to win for some reason, although it has an older timestamp, you can always go to this new and go to this history, and you will see the old one here. So you can see the old show, and this is the old one. It's not the default one, but it's there. You can close this, and if you want this old one to win, you can just manually go and restore this, so then the old one will become what the new one currently is. It'll take its place, right? So your data is never lost. So the good thing is, even if sync sometimes seems a bit fussy, because it didn't really sync without this nudging, it did sync in a lot of databases, but I guess it missed 1 or 2, and we had to nudge it with creating a new entry. I suppose it would have still done its bit after 1 hour, but there you go. There is never a data loss though, so that's a good thing, right? The data might be stale for a while, but there is never a data loss. So we have achieved our goal, so that's awesome. This video was longer than I anticipated because the sync took a long time. So next part, we are going to talk about mobile, and what are the solutions we have, and what I like about them and what I don't like about them. Okay, thank you. Bye.